All right, welcome back. Here we go. Last time we talked about what the derivative is, how it's the slope of the tangent line. I was using the tangent rate of change, and I tried to impress upon you how important it was that you remember that. So we'll see. This is something that we did last time. Given a function, how do we find its derivative? So I told you guys sometimes we call it f prime of x. If the function is called y, you can just call it y prime if you want. You can just say y prime. That means the derivative of y, that's fine. Since this is called y, I'm going to call it y prime. And you do it like this. You apply that definition we saw before, which was the limit as h approaches 0 of f of x plus h minus f of x all over h. So y prime is this function evaluated at x plus h. I'm going to do this first part in blue. So f of x plus h is this function evaluated not at x anymore, but at x plus h, which means everywhere I see an x, I'm going to instead insert x plus h. We learned this at the end of last year. X plus h squared. Remember, this said x squared, but now I'm using x plus h, minus 2x plus h. This, what I've written here, is the same as the thing in the blue box. F of x plus h is this. I'm going to put f of x in a green box. That's just f of x. It's just the same thing. In this case, of course, we're calling it y, but it's fine. I got to remember to put my parentheses so I don't forget to subtract the 2x. And then h is just h. I'm going to write that in the same color as the line. I think that's fine. Now we do some multiplying and simplifying. I can square this thing. If you don't remember the 2xh, I'm just going to stop grading this problem and mark the whole thing wrong because y'all are beyond the point where you should be doing that stuff. So that's minus 2x minus 2h. Then I just subtract both of these, minus x squared plus 2x. The bottom is still just an h. This ought to be, you ought to be recollecting this at this point. You might recollect that everything that doesn't have an h in the top is better cancel out or else you're going to have a problem. Ooh, I've been doing this wrong. God bless America. So y prime is not equal to that. Y prime is the limit as h approaches 0 of that function. That's my fault. You can't just plug the h in because then everything turns to zeros. So we're going to simplify first. Limit as h approaches 0. The x squared cancels out with a negative x squared, a 2x and a negative 2x. I have 2xh plus h squared minus 2h all over h. I still can't plug in 0 because then everything is 0, but I can cancel an h out of every single term. 1 here, 2 here, 1 there, 1 there. I can cross off this guy, this guy, this guy, and the squared goes away. Squared goes away. So I'm left with the limit as h approaches 0. I got 2x, I got 1h, and minus 2. And now I can plug in the 0. Which is 2. And if I plug in the 0 now, this h just goes away, and I get 2x minus 2. So this is y prime. This is the derivative of this function at any point x. If I was like, what's the slope of the tangent line to this curve when x is 0? Now you can tell me. You can say y prime of 0 equals negative 2. When x is 0, the slope of this curve, the original curve, the slope of this curve is given by this function. So when x is 0, the slope is negative 2. When x is 10, the slope is 18. I'm just plugging in a 10 here for x. And so like you get what I mean when I say this is a function because it has an x in it and I can plug in different x's and get different slopes out. So this is how we find derivatives for now. We use this, we call this the limit definition of the derivative. You just plug in whatever your function is and you do simplifying and things cancel out and then you get a function, usually a function. Sometimes it's just a number, which is a function, but usually there's x's in it and then you plug in the x's depending on what the problem is asking you for. If it just says find the derivative of this function, this is your answer. If it says find the derivative of this function when x is 0, you would find this and then plug in 0 to get negative 2. So just to kind of connect this a little bit to our previous question, this is a graph of that function, which I've already forgotten. I think it was x squared minus 2x, right? X squared minus 2x. This is the picture of that. And we said that when x was 0, we wanted the slope to be negative 2. And if you look, I mean, I'm not going to be able to draw it well, but there's 0. I mean, the slope is clearly negative, right? And it's clearly pretty close to -2. Like if I drew a straight line from there to there, I feel like I would get negative. I feel like this is a pretty good approximation of tangent line, and its slope is -2. So you're like, okay, maybe we can do it backwards. If I look at this graph and I'm like, well, I bet that when x is 1, right here, I bet the slope is 0. It looks like it is, right? It looks like the slope is 0. So is y prime of 1 equal to 0? Is the slope of this graph when x is 1 equal to 0? Let's go back to our derivative we found. And we're like, all right, well, what's y prime of 1 going to be? Well, 2 times 1 minus 2, oh, it's 0. What do you know? So we were right looking at that picture. It looks like the slope should be 0 right here. And it is. The graph tells me, right? We said y prime is 2x minus 2. So we've now calculated a derivative for the first time ever, at least knowing that it was a derivative. Y'all did this last year, but now we know for sure it's a derivative. A more common type of AP question, and it'll be a question on my test, is like, here's a function, here's a point. That's just an x value, but you could figure out the y value. And it says, I asked you guys to do this last year, find the equation of the tangent line to the graph of that point. Not just the slope, but the whole tangent line equation. So for that, I think last year I was like, if you want to, maybe the first thing you do, this is gonna give us the point, and then we're gonna use this thing to find the slope. But to find the point, we could do like, this is the x, we could find the y right off the bat. So we could say for x equal to negative, that's an f, so I'm gonna erase that. For x equal to -2, f of x equals 5, I think, right? -2 squared, 4 plus 1 is 5. So our point is going to be -2, 5. And now we got to calculate the slope. Sorry, excuse me. We got to calculate the derivative. So I'll do this one. What's the next one? Let me see what the next one is. So I want to do one with the other one. Yeah, I'll do it this way. So we'll use the same. I'll use this function here. Yeah, we're given the x value. Let's do it exactly like this. So let's do it like we did the previous one. So I'm going to use this, but I'm going to say x's. I'm going to use x's here. X. F prime of x. So f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So I'm just going to do that. I'm not going to rewrite that. So since this is my function now, x squared plus 1, first I plug in x plus h in here, and I get x plus h squared plus 1. It was x squared plus 1, right? But now it's x plus h squared plus 1 because this says f of x plus h. Minus f of x, which is x squared plus 1. The bottom is just an h. And now we do our foiling in an appropriate way because we're smart and astute calculus students now. X squared plus 2xh plus h squared plus 1 minus x squared minus 1 all over h. And now we cross some things out, hopefully. The 1's go away, the x squareds go away, and we're left with the limit as h approaches 0 of 2xh plus h squared all over h, which is the same as, or simplifies to 2x plus h, which becomes 2x when you let h equal 0. So the derivative of this function at any point x, at any x value, is 2 times that x value. So when x is 0, the slope should be 0. And when x is 1, the slope should be 2. And when x is 10, the slope should be 20. My x that they asked me about was this x equals -2. So if x is -2, so slope of f at x equals -2 is -4. So this is my slope. This is my point. Now I can write the equation. Y minus 5 equals -4 times x plus 2. remember y minus, I'll write it up here just so you remember, y minus y1 equals m times x minus x1. We call that point slope form. And when you're doing these problems, asking for the equation of the tangent line, this is by far the easiest way to do it. Some of you are you might use y equals mx plus b, but I say don't do that. I say use point slope form because you can just stop here if you want to. You can also like simplify this thing and like turn it into point slope form. You get negative 4x, that's minus 8 plus 5 is minus 3. So I don't care which one of these answers you give me. This one works, it's all fine. But this one is fine, so if you use point slope form, you just do this and then you're done. You don't have to convert it. Or when you do this one, mx plus b, you all tend to like plug in this and this and this and find b and then plug things back in. You can do it that way. It just seems like more work to me. So do it if you want. Don't. I think this way is much more straightforward. So this is like a reasonable AP question. It's a little simplistic, but it could easily be on there. So pay attention. All right, here's another one. I'm gonna use this one this time, just to show you guys what that would look like. This is like find the limit at a point. So the question is the same. Sorry, find the derivative at a point. The question is the same, find the slope, find the equation of the line tangent to this curve at this x value. But I'm gonna do it this way just to show you guys what that would look like. This is the limit as x approaches a of f of x minus f of a over x minus a. And here my a is gonna be 2. I'm gonna use this x value as a. So the limit as x approaches a, f of x is just this thing, 5 minus x squared, minus f of a, so a is 2, f of a is 5 minus 2 squared. All over x minus a, so x minus 2, because a is 2 in this problem. So let's keep going. 5 minus 5 is 0. And then I'm going to get negative x squared plus 4 over x minus 2. This looks a bit like a difference of squares, except it's like backwards, right? So there's kind of two ways to think about how to simplify this. Uh-oh, I forgot the limit. Don't do that. I'm modeling bad behavior here. I apologize. Cannot forget to write the limit. I know I just did, but let this be an example of what not to do. So I got the limit as x approaches a. I'm going to factor a -1 out of the top of this thing. So I'd like factor out a -1, I get x squared minus 4 on top. That's just to make it so I can factor it more easily. You could have switched the order and then made that one negative, but it doesn't make any difference. So this is now x minus 2 times x plus 2 over x minus 2. So it's the limit. I keep writing x approaches a, but I know what a is. Should be writing as x approaches 2. 2, 2, 2, 2. Limit as x approaches 2. And now it's what's left? Negative x plus 2. Now, up until this point, I had that same problem where I couldn't plug the 2 in, but now I can. So now I plug in 2 for x, and I get negative 2 plus 2, which is -4. So the slope of this curve at this point is -4. Let me just kind of draw the distinction, specifically draw attention to it. When I do it with this limit at a point A trick, I get a number -4. If I had done it this way, I would have gotten like -2x and then plugged in the 2 and gotten -4. So to some extent, it's like a little more work, but you can do it either way. And remembering both ways is really important. So here's my slope. And the point is, so x is 2. And y, g of x is 5 minus 2 squared is 1, right? So my point is 2, 1. My slope is m, so I do y minus 1 equals negative 4 times x minus 2, and I'm done. If you're feeling like doing it this way, you get negative 4x plus 9. It's like a point. It's like a slope-intercept form, but either one of these answers is fine. I really don't care which one you use. Well, let's leave that one as an exercise for the reader, so to speak. I'll probably do this one, and then we'll be done because I don't want to talk about this until you guys can watch me do it on an emulator, which I don't have yet. So we'll either do that later or we'll do it in school. You don't have to know how to do that today. So this one's a little trickier because of the square root. I feel like we did these last year. Excuse me, you'll pardon me if I'm mistaken about what we did or didn't do. I think we did these. So this is f of x plus h, right? If f of x is root x, then f of x plus h is root x plus h minus root x all over h. And now I can't factor this like we did before, so instead we multiply by the radical conjugate. Plus, remember, this is the difference between, this is what the radical conjugate is. The minus outside, the minus in between the terms turns into a plus. You gotta do that to the top and the bottom. Really bad about drawing those lines too long. And we get the limit as h approaches 0. And I multiply these two things. I get the first thing squared minus the second thing squared. So I get x plus h minus x. If you're not sure how I did that, you can think about it. You can actually multiply it out and see that it's true, or you can think about the difference of squares, which is always what I do. And now this times this on the bottom just stays there. My recommendation has always been, don't multiply out the bottoms of these when you're doing this radical conjugate thing, because it's never going to help you to have that thing multiplied out. It's always going to help you to have it factored. Limit as h approaches 0 of these x's cross out. I'm left with just h on top. And conveniently, there's an h still multiplied on the bottom because I didn't distribute that h. And now I can cross those off, and I get the limit as h approaches 0 of 1 over root x plus h plus root x. Now I can plug in h equals 0. So the limit I get to stop writing the limit now. When h is 0, this is just root x on the bottom. And that's also root x, so I can add them together. That's 2 root x's. And this is what is the derivative of the square root of x, 1 over 2 root x. And this is one I recommend memorizing this one. It just shows up all the time. And being able to do it this way, we're going to learn how to do it with powers in a minute or in a couple of days or whatever. There'll be a lesson where you do it, and it'll be fine. And you can use the power thing, but knowing how to do it this way is going to make your life much easier. The derivative of the square root of x is 1 over 2 root x. It's good to know that. I'm just telling you it is. It's just handy to know that thing. So this is how we find derivatives of functions. We use this, when we use this limit definition, you just plug it in to, I'm going to go back to this, forgetting just to remind us, we plug it into this expression generally. I showed you guys how to do it with the derivative at a point. This is a derivative at any x, derivative at a specific point A. This is how we find derivatives. They are, vitally and importantly, the same as the slope of the tangent line to the graph at a point, and that's the same as the instantaneous rate of change at a point. This is a geometric interpretation. This is like a more general, kind of a general interpretation. This works for any function, whether or not it's represented as a graph. So hopefully y'all understood that. If you have some questions, come up with them, think about them, ask me in class. Goodbye.